Hey everybody, my name is Björn Wagner from Parity Tech, and I have the pleasure to tell you a bit about one of our newest systems, which is, hold on. I was told to hold on for a second. Okay, got it. Awesome. So I have the pleasure to tell you a bit about one of our new systems. It's called Parity Bridge today. Over the next half hour or so. So please bear with me. Sorry for taking your break, maybe, if you stay here. And I hope I'll be able to show you a demo as well, but that's not quite clear if that's possible because of the tech setup here. So, Parity Bridge, right? Just a bit about the background. As some of you might know, we have been working on a next generation blockchain protocol, which we call Polkadot. It's a kind of a multi-chain framework, and one part of it is the system that we call Parity Bridge, and that's supposed to allow Polkadot, this multi-chain network, to connect to independent blockchain networks, such as Ethereum. So, such as a network that provides its own means to come to consensus, its own canonicalization mechanism, rather than these other elements which we call parachains, which lend its means to come to consensus from the Polkadot network. That just as a background. And Parity Bridge is really the project that is prototyping such a system. And along the way, we figured out that it could be very useful right now for other things. So what problem could it potentially solve right now? As many of you know, right, and I would be really interested to find out later how many of you here are ΔApp developers and have been working on certain ΔApp smart contracts and so forth. As many of you know, we are confronted with the problem that the Ethereum mainnet still doesn't scale, even though we've been live since 2015, summer 2015, and it currently doesn't look like the Ethereum mainnet will scale for at least another 12 months. And I know this is a rather difficult discussion, what means scaling and so forth, but we just had this wonderful meetup in gathering in Barcelona these past 2 days with a lot of teams that work on scaling solutions, rather near-term scaling solutions, or mid-term scaling solutions such as the Plasma team, L4, that counterfactual that works on state channels, Raiden and so forth. And it really turned out that none of these solutions that people are working on like the rather good solutions, will be available for at least the next 6 to 12 months. And what we see is that there are quite a few projects now that have been working on their dApps for over 2 years. And they are in a state where they have written up their smart contracts, they have tested them on a testnet, and now they really want to go to the next phase. They want to deploy it and test some user interactions with real value, because the user really, really interacts differently if real value is involved or not. And just to name a few of them, there's Giveth, there's Colony, there's Gnosis, that are all pretty much ready to go live, but they can't for 2 reasons, right? And they are obviously interconnected. One is the high transaction costs on the Ethereum mainnet. I mean, if here I put some statements from blog post or like just from my conversations that I had over these past 2 days, if Gnosis, any trade cost $1, that's not really viable. Neither is what Giveth is trying to do good, and then you have to pay $11 for creating each milestone. So that's a real problem that these ΔApp teams are confronted with right now. And there are pretty much only 3 options for them, right? So either they stop working now, they say like, hey, you know, I'm going to wait for another 1 year or 2 years or whenever the mainnet is ready to scale, or maybe, you know, I throw away all my smart contracts and think about how that could work with state channels, because state channels require a very, very different way to architect your ΔApp. Well, or you deploy on a testnet, but then you are left with the issue that you don't have real value there and can't really test user behavior. Not to talk about all the network congestion that we've seen from all the ICO craze and CryptoKitties craze. So, what can we do? Parity bridge, what is that? Right? Parity bridge is a federated bridge between any two EVM-based chains, networks, that relays arbitrary messages from one chain to the other. It connects two chains, right? We call them home and bridge. And the bridge really consists out of, I would say, three parts, right? One part is Rust software that connects to two Parity Ethereum nodes, each running one of the two chains, home and foreign. It consists of two deployed EVM contracts, one on each of these chains, right? And the nodes track any events in these contracts and interact with these contracts. And last but not least, entities in meat space, which we call authorities, that run the system, that run these nodes, the bridge software, and validate and relay messages between those. Functionality, what does it provide, right? It allows actors on one chain to call any function with any parameters on the other chain. And its security relies on authorities that run the bridge and the other network. So, authorities have to be trustworthy, but the overall security of the system can be equal to the foreign chain security. So the security trust model that's behind the other network. And that is mainly because all relays between these two chains have to be signed off by any authority that is running the bridge. So they see transactions saying like, hey, I want to relay that message. And they look at them, validate them, sign off on them, provide a signature. Once enough signatures have been gathered, this relay is being fulfilled. And we try to keep it as simple as possible, simple abstraction, don't put in too much fancy stuff, and we want to get to a state where it's so flexible and general that it can really cater for any potential use case that people would have on each side of the chains. So, how can that mitigate scaling issues that we have right now? How can that help ΔApp teams that are in a state where they have contracts that they want to test with real Ether? Well, two things, right? We can offload the transaction load to another network. And since we already have networks, proof of authority networks, that provide more throughput than what is possible on the Ethereum main chain, that can really help. Currently, we can provide a throughput that is 10 times to 100 times higher than what we have on the mainnet. And also like additional features or additional improvements such as lower latency, lower block times, faster finality. Right? On the Ethereum mainnet, you usually wait at least 12 confirmations before you consider something, relatively final. In a proof of authority network, you have a different model, and you can be sure that something is final on that particular network way earlier. So how can that help mitigate the scaling issue? Well, you could potentially, if you can call any function on the other network, you can spread up your ΔApp to two networks, right? And I want to give you a few easy examples that came up by talking to all these ΔApp teams over the past days, weeks. For example, look at Giveth, right? Giveth have a ΔApp that allows users to donate for good, and then take some decision-making process how these funds should be used, how they should be allocated, right? So there are two parts of it. Number one part is deposit Ether into the ΔApp, and then take some decisions based on that later on. So the real value, the Ether, right, the Ether that has real value is locked in the Ethereum mainnet. That doesn't exist on the testnet. Now, if you have a bridge that allows you to wrap this Ether on the real mainnet in the sidechain, let's for example say Coven, right? Suddenly you have a wrapped Ether token on Coven. Then this can be handled just as real Ether on the main network and has the value, right? So what you could do is like, Giveth could say like, hey, one part of my ΔApp lives on the mainnet, and most of the other parts live on this other network, for example, Coven, where all these transactions happen. So I save a lot of transaction costs because transactions are cheap on Coven or currently for free, right? And there are different examples, right? On the left side, you see the ETH to ERC20 use case, right, where you wrap Ether on the main chain and have has the wrapped Ether as ERC20 token on the side chain. This is relevant for a few projects. Another one is where you have an ERC20 token on the main chain and you just relay, like deposit it on the main chain and make it available to the same user who deposited on the main chain on the side chain. Let it be Coven. And the user can do whatever he wants with that wrapped Ether on there. So that is very interesting, not only for example, Swarm City, Dragonerium, but also for somebody, potentially somebody like Radar Relay, right? Who, where you could assume that the user, right, wants to use their ΔApp quite often and only deposit once and withdraw once over a certain period of time, and in between do a lot of trades, right? And that would be really, really expensive on the main network, but if you split your ΔApp off, you only have 2 transactions on the main network, the deposit and the withdrawal transaction, and any other trade on the side network. And there are a few other use cases where you need some more custom solution, where you need this arbitrary messaging function rather than just wrapping Ether and making it available as ERC20 token. So this is where we want to get, and we are pretty confident we can get there in like 1 to 3 months, I guess. And I just want to talk about the current state of the solution that we have, the current state of Parity Bridge. So the current state of the Parity Bridge is an ERC20 token on one EVM-based blockchain that is backed by Ether on another EVM-based blockchain. And we currently have that deployed and running on Robston and Coven. So there are a few assumptions we take. Number one, the assumption is that the home chain, which would be probably the main network, has higher transaction costs than foreign, and foreign uses a POA consensus mechanism. For multiple reasons. One of them is, obviously, the authorities should be able to make free transactions. And the other reason is, if the transaction costs are not lower on the foreign network, obviously you don't gain anything. Therefore, we tried in our solution to minimize any transactions that would happen on home and try to offload all the transactions in the bridging process to the foreign network, in that case, Coven. The current solution is built so that the bridge authorities, so those that come to consensus and relay transactions, are immutable after deployment. So we have a fixed list of authorities in the contract when we deploy it. This can be fairly easily be extended to with some kind of governance process. For example, you could have a majority vote where the authorities say, hey, I want to onboard this and that project to also be an authority. And I will talk later a bit about where we want to get eventually. What happens is the user deposits Ether into the home bridge contract on home and gets the same amount of ERC20 tokens on foreign. And users on the foreign bridge side, so on Coven, can use the wrapped Ether just as any other ERC20 token. And last but not least, relays between the chains happen in the Byzantine fault-tolerant way. And this is a bit of a wrong usage of that expression, in my opinion, because you usually rely on, like, talk about that in consensus systems, but in some way or another, it's more true than false. Just to show you roughly how it works, right? Here, see on the left side the home bridge contract. The user sends a transaction that deposits Ether into the contract. There's a breakout event. The bridge authorities listens to that event. They track them. They see it. Then they validate it, provide a signature, sign this event, provide that, send that to the contract on the foreign side, on Coven, where transactions are very cheap, right? They are gathered there, and once a certain threshold of authorities have provided their signatures, an event is triggered, and the ERC20 token is being minted. And the same way around, if the user wants to withdraw their Ether from they have wrapped Ether from Coven to the mainnet again. A similar process happens, just that all the signatures are again being gathered on Coven rather than on the main network, because transactions are cheap on Coven. So, in what cases can that be useful? This particular state of the bridge, right? Like, who should be really interested in that? In my opinion, any dApp, right, that has users that want to send any kind of Ether to an app and then do more than 2 transactions, interact with the dApp more than 2 times between any deposit and withdrawal. So I asked around a few projects, and for example, CryptoKitties told me that's roughly for them 10 to 100 transactions per user, right? A user provides some Ether, does a lot of things, you know, trades, whatever, puts hats on, I don't know, and then withdraws the Ether again. And there are 10 to 100. So that is a lot. You can save a lot of gas, you can save a lot of costs. Same with any kind of gambling app, and similar with Giveth. It would be the same case. A few UX considerations obviously apply. Number one, right, if the user keeps interacting with the dApp, right, he sends the Ether, he needs to be on the main network while sending it. So MetaMask, for example, if you use MetaMask, has to be set to the main network, and then once the deposit is being made and the wrapped Ether is being made available to him, he has to switch MetaMask to the other network and interact with that. Pretty straightforward, right? And the second consideration for sure is users need to own native currency on the other chain as well, which is kind of unfortunate. So, roadmap. Where do we want to get? What do we want to change? Number one, thing where we want to get quite fast is we don't want to have the bridge authorities be a fixed set that we have to determine when we deploy the contract, but rather we want this set to be tracked. We want the bridge authorities to track the set that maintains integrity of the POA network. So as all of you know, a POA network, right, has a validator set that that comes to consensus and provides a finality mechanism for the other chain. And we believe that the trust model is pretty similar, right? If the user wants to use a dApp, he has to kind of trust that not a majority of the POA networks authorities collude against him and forge any transactions. And in the same way, the relay between the networks has a similar trust model. So it really makes sense that these two set of parties are the same. So if you imagine, like on Coven, right, we will get to a point where we have dynamic validator sets. That means that, for example, currently there are 9 authorities, 9 dApp teams, right? And they decide, hey, we want to onboard another one. They do a majority vote. This one is voted in as an authority to maintain integrity of the POA network. This same authority should be onboarded as a bridge authority as well. So this is one part where we want to get over the coming month. Another one is abstracting over the special use case from ETH to ERC20 to arbitrary message passing. And I just want to point out one really cool use case that came up when I was talking to one of the maker guys 2 days ago, which is, imagine you could set up a new POA chain, right? A new chain, or potentially even Coven, and have the native currency on that side chain be DAI on the main network. So a user who sends DAI on the main network to this bridge contract gets native currency on the other one, so Ether. So you would have a stable coin as Ether on this other chain. I think that's quite cool, and we have an idea how we can get there quite fast by allowing the bridge system to enact state changes on the phone chain. So I'd love to show you how that actually works right now and walk you through that. But as far as I was told, this is not possible because you don't have Chrome, right? You only have Safari and no MetaMask. So the only thing that I can actually do is show you a few things that we have built around that. So, does it work? Yeah, how can I show that somehow?
Yeah, sure. It's Safari, right?
Yeah.
Yeah, so just drag it on this screen.
Up?
Yeah.
No?
On the right. Should appear. Yeah.
Woo.
Okay.
Here we go. So what we have, for example, is a dashboard that tracks whatever happens right now on our deployed initial version between Robston and Coven. So you can see, for example, the status that shows you just like some information from the contract, which is, for example, how many signatures are required for any relay, right? We can configure that. It could be 10 out of 10. It could be 7 out of 10 authorities need to provide the signatures. Here it shows the authorities. Currently, we have only one. This is our node that's running. The estimated gas cost of a withdrawal transaction on the main network. We have limited how much Ether can currently be deposited in a single transaction, as well as the max total balance that can be held on the main chain side of the bridge, just for testing reasons, security reasons. We don't want to have a fuck up, as you all can imagine. And I think these phases are quite sensible. But this is all configurable. So whoever here feel free to set up your own POA network, just deploy the bridge. You can do a lot of cool stuff with that, I think. Or just test it between Robston and Coven. And we would love to deploy that between mainnet and Coven at some point, or mainnet and maybe another new network that is a bit less of a testing network, so that, for example, the dApps that want to use this kind of scaling issue mitigation strategy could have a bit more confidence that there will be no breaking changes. So what we've been talking about in Barcelona, for example, is like there could be some teams have voiced that they might be interested in setting up a new POA chain where they do a few pledges. Number one, they say like, hey, you know, this is kind of a test network, but we say like, hey, we have real value on here. Maybe limited value, but real value. We don't want to try really cutting edge features such as Casper network, right? We need our dApp to be running over the next year. So that, and second of all, which I think is really important, that everybody would do a pledge and say like, hey, you know, we acknowledge that it's not the vision, the future where we want to get, because, right, a POA network is not why we are all working here, right? But to be honest, this is the only way we can see how dApp teams can actually test user behaviors with real value right now or over the next 6 months. So it's just, in our opinion, a fair approach if teams decide to do that. But in my opinion, it makes sense that you do a pledge if you decide to go down this route and say like, hey, you know, I'm actually committed to the main Ethereum network, or like a full permissionless system, and like this is only an intermediary step to get where I want to get. And you can check that all out in our GitHub, right? It's all open source, Parity Bridge. There's a user guide as well. There's a deployment guide. I don't know if you can see it. This dashboard is live as well. You can watch the, yeah, it's a bit hard to see here, but basically what you see is like when a deposit comes in, here it shows you how many, what's the block depth of that transaction, so how many confirmations have we seen. Once there are 12 confirmations, for example, the first authority says, oh, great, right? I've seen 12 confirmations, so I say like, hey, this relay should happen, I provide my signature. So in the middle you see that it's the one Parity node that's running currently, the bridge node, but there would put probably, like there should be like 10, 20, however you want, and once a certain threshold has provided their signature, the transaction actually happens. And what you can do is you can track that all on Etherscan, so you can check it all out. The contracts are all verified, so you can read the source code. Here's Homebridge. You can actually interact with it. Yeah, that's pretty much it. And now I would love to take the time and take any questions you have.
Thank you very much. Just a small question. You mentioned it's all networks that EVM based, right? And definitely there are a few more projects that EVM based and derived from Ethereum. They will be compatible with this bridge as well, or it?
For example, other networks. There are many networks.
Ethereum Classic, or?
Say again. For example, POA network, right?
No, but Ethereum Classic.
Of course.
For example, is
I wouldn't
EVM based.
I wouldn't see why not.
Yeah,
Yeah.
Ubiq or.
Yeah.
Okay.
I mean, does Parity currently supports Ethereum Classic?
Yeah.
So that should work, yeah.
Okay.
I don't think they did any changes to the EVM that
Okay,
should
so
break that
if
system.
the EVM is not changed, that means if the EVM is not changed, that means it's compatible with the bridge.
It should be, yeah.
I see. Okay, thank you.
Could you use the same technology to bridge different blockchains, so not Ethereum-based?
Well, in the future, it's meant to do that. For Polkadot, right? We want to bridge, for example, Bitcoin to the Polkadot network, but that requires a lot of modifications, obviously, because these authorities, like currently, right? How it works, it's pretty simple. You have kind of a multi-sig on the main network, right? And in Bitcoin, you have a lot of limitations currently. For example, how many participants you can have in a multi-sig, right? But we are fairly confident if, for example, Bitcoin moves over to a different signature scheme, for example, Schnorr signatures, where the size of the final signature doesn't increase with all the signature authors, then we could potentially get there and achieve that. That has yet to be seen. But in general, any kind of smart contract-enabled blockchain should be able to be bridged in the future.
But do you have any roadmap for other blockchains? Or not yet?
Currently, non-particular. So, right, obviously, Ethereum, all EVM-based, which are supported right now. But there are not many other smart contract-enabled blockchains that are up and running right now. So it's kind of difficult to say. I don't know enough about the Neon execution environment to talk about that, but I'm really happy to discuss that or look into that. Even though it would be quite hard, I don't know if I would want to do that because in terms of consensus mechanism, the guarantees the Neo network gives you right now, I'm not sure it provides you the guarantees that you should have to make value available on another network.
Okay, thank you very much. I got a small question too. Is it
Thanks.
is it possible to build a bridge between a private and a public network?
Of course. So what is a private network? That's a good question. So the way I talk about it is usually the following way. You have public networks and private networks, which means public means anyone can connect to it and look into it. And private network is more like a VPN network that nobody can connect to. The other dimension I would usually discuss about is like permissioned, unpermissioned. And there are so many different levels and layers where you can permission a blockchain system. For example, who can connect to the network, who can't connect to the network, who can participate in the consensus mechanism, right? In proof of work, it's really unpermissioned, that level. In proof of authority, it's a bit more permissioned, right? Because the current authorities have to onboard any new authorities. But if that's what you mean, with private network, then obviously, and that's what we talk about. So you could have an enterprise network that says like, hey, you know, I want wrapped ether. I want ether value on my chain. And you could make that happen with that exact solution, yeah. If that answers your question. Yes, please.
Yeah.
Oh, sorry, yeah.
So firstly, this is a great effort, and it is actually a pain point that you are really targeting. So my question would be that a transaction, an ideal transaction, would just do a withdrawal or a token-related transfer in the mainnet, and the rest of the transaction could be carried out on, suppose, say, Coven. So doesn't this bring a loophole in security for the transaction? So because there's a bridge between two different networks, doesn't this bring in a security issue?
Well, we got to be we got to be very specific about that, right? So once you offload transactions to another network, right? These transactions are secured by the other network. So these security or the security considerations of the other network applies to your transactions. But if we talk just about the relaying mechanism, right? It's pretty straightforward. Let's assume the authorities of the bridge who relay are the same authorities as the ones that secure the other network, right? And you require a majority or supermajority of authorities to provide their signature to relay any kind of transaction. Then you kind of get the same security guarantees, right? Like none of the authorities can like just steal ether or any kind of other stuff. They can't forge transactions anyways. They can't forge a signature, as you know. And yeah, does that answer your questions?
So,
or?
yeah, the question was that I want that transactions X, Y, Z should be carried out once this amount of ether has been deposited on the network. So, you know, the connection between the two transactions, that this has to follow the first one.
Okay, got you. Well, so if you deem the security model of the side network trustworthy, right, of like this POA network consensus mechanism, and the bridge security model follows that one, then, and you say like, hey, you know, the user sends a transaction to this other network by providing some ether and some kind of calls a function. Says, for example, when my ether is wrapped on the other side, do this, that, and that, and this is a transaction. Yeah. And you trust the security model behind it, then this will happen on the other network. The message will be relayed, and once it's relayed, it will be executed on the other network. And there are a few things around it, like we designed it in a way that even if the authorities, so what happens is the user calls, like kind of makes, says like, hey, you know, relay this message. Then the authorities gather the signatures, and then in the end, someone has to submit another transaction saying, hey, here are all the signatures, so this is valid, do it, right? And even if none of the authorities do that last step, if that would happen, the user could do that. The user could trigger that himself, right? So in that particular case, what you're talking about, I don't see any security considerations beyond what you would have concerning a POA network or the collusion that they collude with each other.
Thank you.
For sure.
Hi, I was wondering, is it possible with the Parity bridge basically to do some kind of like child chains? So you get a bridge from the main to the child, and from the child to another child, and so on, or is like one A to B?
It can connect, it can relay messages between any two Ethereum-based networks, right? EVM-based networks. So there is nothing that speaks, again, like having one network connect to the other and this network to the other, but there's one thing. The current design assumes that one of the networks is a high-value, high transaction cost network, and the other one is a low transaction cost network. And specifically, it assumes that the other network will, or that's where we want to get, will have some means to come to finality, not like probabilistic finality in proof of work, but rather like determinate finality on a POA network, so that at some point you can say, oh, right, this is really final, and speed up the relay back. Okay. But potentially not. And POA network is actually looking into that because they want to connect a lot of POA networks with each other, and they're using Parity Bridge and building on top of that. Okay. So nothing that fundamentally speaks against it.
Okay, thanks.
Yeah, of course.
Hi. Maybe I'm missing something here. My question has to do with volatility. If you're depositing Ether on the home bridge, to what extent can volatility affect the token that you get on the foreign chain.
Could you repeat that?
Sorry, yeah, my question has to do with volatility. If you're depositing Ether in the home bridge, in exchange of which you get token on the foreign chain,
Yeah.
what happens if the Ether that you deposited, like the value drops 70%? Is that a risk? Is that?
I mean, so the bridge just makes sure right now that one Ether, like one ERC20 token, like the bridged Ether on the side network, is backed by exactly one Ether on the main network, right? So at any time, like it doesn't matter who sends, like I could, for example, deposit Ether on the main network, get the wrapped Ether on the side network, send it around to somebody else, and it doesn't matter how many transactions there are in between. This exact Ether, bridged Ether, will always be backed by one Ether on the main network. That's the guarantees that the bridge provides you with. So, right, same volatility, except you have, for example, you use DAI, right? If you would bridge the DAI over to the side network, it has the same kind of volatility constraints as anything else. So, yeah, it's nothing specific to that. Any other question? Okay, I would be. Oh, yeah, there was another question up there.
Okay, the last one, and then you can continue on the Slack channel maybe.
Yeah.
It's good for me.
I am wondering what do we need to run to have a bridge between two blockchains? Like, do we need to run something, or we can connect to existing validator?
So, as I said, right, for example, currently this is deployed between Ropsten and Coven, and you could just use it, right? Connect your ΔApp, your smart contracts to these, make them interact with each other, and like use that system. Or you say like, hey, you know, I want to use a different POA network, or I want to set up my own POA network, or I also want to be a bridge authority, right? And then if you want to be a bridge authority, obviously you have to run code. You have to run these two nodes in order to be able to provide these validation function. Yes. I would be interested to find out if who of you are ΔApp developers? So actually developing that. Who of you actually have the problem right now that they are in a state like where they could potentially deploy something, but it's too costly? Oh, that's a lot. So like, who of you think that even the current state of that, so the current state is ETH to ERC20, can help you guys? The current model where you deposit Ether on the main network and you get a wrapped Ether token, so an ERC20 token on the side network. Who of you think that would be enough already? Okay, cool. Okay, cool. Who of you think that if, you know, it would provide the function to transfer arbitrary messages between these two networks so that you literally can just split up your ΔApp contracts as they are right now into two parts, one that runs on the main network, one's on the side network? That would solve it. So these are a lot more, right? So 1 to 3 months, and I would love to see you in our channels here. You can't see it. So we have a GitHub channel, Parity Bridge. We have a Riot channel, Parity Bridge. And obviously the Parity Bridge GitHub repository, and it would be really awesome to get in touch with you, hear your use case, and figure out how we can cater for that use case. Thank you so much.